Under 4.2, we are going to understand something to do with reciprocal graphs. And we are being told that you can sketch graphs of reciprocal functions such that y is equals to 1 over x. You can also have y is equals to 1 over x squared. And you can also have y is equals to minus 2 over x. Of course, by considering their asymptotes, you must remember that if we are dividing by a variable that is at the denominator position, this variable is not supposed to be 0 because any constant over 0 is not defined. So there will be an asymptote when the variable is supposed to be 0. And in this case, the graph of probably y is equals to 1 over x, let's start with this one. The graph of probably y is equals to 1 over x. Let's just sketch it over here. The graph of y is equals to 1 over x. Assuming x is 1, the graph of 1 over 1, y is 1. Assuming this is 1 and this is 1. But as y approaches infinity, let's do it here. As x approaches infinity, positive infinity, 1 over a very big number, you will see that it is not equals to 0, but it is approaching 0. So, as x approaches infinity, y approaches 0. And I want you to look at this. 1 over a very big number, 1 million, 2 million. It's going to be not 0, of course, but a very small number. But as x approaches 0, very close to the y-axis, we are going to have 1 divided by a very small number, very, very small number. Then y approaches infinity. And we're going to have our graph that looks like that, for x values being positive. But when x is negative, of course, it follows the same, but this time y will assume negative values. So the graph you see here, this is the graph of y is equals to 1 over x, the two curves. Let's talk about a graph like y is equals to minus 2 over x for that matter. Note the constant is negative. How is this going to be? When x is positive, negative divided by positive, we are going to have a negative number. So when x is a positive number from this point to the right, negative 2 divided by any positive number, we are going to have a negative number. Of course, the rule of asymptotes still holds. But when x is going to be negative from this particular point to the left, then minus 2 divided by minus anything, we are going to have a positive number. And the rule of asymptotes still hold. So this is the graph of y is equals to minus 2 over x. But let's talk about something else. Let's talk about y is equals to 2 over x squared. Now, you have something to consider here in a very special way. When x is squared, it doesn't matter whether it was negative or positive, it will always maintain positive number. So you can see x squared is always greater than 0. And for that reason, we will always have the value of y positive. So we'll have this graph will never touch. These graphs will never touch. It's an asymptote. We'll have something like that when x is positive. But even when x is negative, a negative number squared remains positive. So 2 divided by any positive number, all the values of y, regardless of the nature of x, will always be positive. And that is the graph of y is equals 2 over x. But let's see when probably we have y is equals to minus 5 over x squared. Minus 5 over x squared. You have already known that x squared will remain positive. But look, minus 5 is dividing a positive number. So we are very sure, regardless of the value of x, whether positive or negative, due to the presence of the negative sign at the numerator, we will always have a negative value of y. The rule of asymptote still holds. So even when x is a negative, x negative squared becomes positive. Minus 5 divided by a positive number, we always have a negative value of y. And this is exactly what we are talking about. So you will see, you will always see something of this nature. It is important you note the nature of the graphs. These are the sketches. Consider when we have asymptotes and always remember how they behave. We have just said if you happen to divide by 0, then that value is undefined. And that is why we have an asymptote. All through along the y-axis, we have an asymptote. At the same time, when we have a constant number divided by a very big number, and I think I've highlighted here, then the quotient is, though it is not 0, it approaches 0. And you will be able to remember all this. All right?